Welcome students to the class of speed, distance and time. Today we'll be learning about the concept of speed. Okay, so when we talk about the motion of an object, we talk about speed. When an object is moving when the object is changing position with respect to time, we are interested to know how fast it is changing the position. So speed can be understood as distance covered per unit time. The commonly used units are kilometer per hour, meter per second, miles per hour as used in the UK system. I'll give you an example. Suppose I say that an object is moving with 40 kilometer per hour. It means that in one hour, it travels 40 kilometer. So in 2 hours, it will travel 80 kilometers and so on. The speed will not always be given, may not be given in unit time, so we have to change it by using unitary method. Okay, let's move ahead. We can use this speed distance time triangle, and this helps us to remember the formula. Distance is equals speed times time equals distance by speed is equal to distance by time. Here is a problem. A cyclist covers 45 kilometers in 3 hours. Find the speed of the journey. So speed equals distance by time. Distance is 45 kilometers by 3 hours will be 15 kilometer per hour. So in 1 hour, the body travels 15 kilometers. Okay. Primarily our concern will be in speed distance time problems will be concerned with motion in a straight line. So let's see what are the different possibilities. When we talk about when we talk about two instances of a journey such that distance traveled is same, in such a case we can say that the speed is inversely proportional to time. Speed is inversely proportional to time. Okay, so remember the formula S equals v by t. So speed is inversely proportional to time. What does it mean? For a constant distance travel, if time taken is more, the speed has to be less and vice versa. And in that case, you should remember that the ratio of the speed of the body will be equal to the reciprocal of the ratio of the time taken by it. Or you can say that the product of S1 speed and the time in one instance will be equal to the product of speed and the time taken in the second instance. Similarly, when time is constant, the speed is directly proportional to distance. It means that for a given time, if distance traveled is more, then speed has to be more. This is what is meant by the second example. Case 3, when speed is constant, distance is directly proportional to time. What does it mean? So if the speed is constant and you are taking more time, it means you are traveling more distances. Yeah. So these are the three uh, relationships you should remember, which will help you to solve questions fast. Okay, let's move ahead. Okay, let's see a problem asked in TAT 2004. A man cycles at 10 kilometer per hour. He arrives at a certain place at 1 p.m. and when he cycles at 15 kmph, he will arrive at 11 a.m. So what speed he must cycle to get there at noon? So one thing you can see here, sorry. So one thing you can see that distance is constant. We are talking about same distance over and over again. Suppose this is the initial position, this is the final position. Let the distance be x, and to travel this distance at 10 kmph, it takes time t, and that's why it reached at 1 p.m. I don't know when is the start of the journey. Let's suppose it is it takes t hours. It's also given that at the speed of 15 kmph, it reaches the same place at 11 a.m. That is 2 hours before that. So we can say that the time taken will be t minus 2. And now we know that distance is constant. We can apply this relationship from here. We'll get 10 upon 15 equals to t minus 2 by t, which implies that t you will get is 6 hours. If t you get is 6 hours, then distance you can find to be, distance will be, uh, what will be the distance? It will be speed into time, that is 10 times 6, that will be 60 kilometer. So, at what speed must this cycle to get here at noon? At noon means 12 o'clock. You want to reach the venue. So, the required speed, the speed required will be, distance covered will be 60 by time taken. At 12 o'clock, it is 1 hour behind 1 p.m. So, whatever the t is, you go 1 hour back, that will be 5, 60 by 5, that will be 12 km per hour. Let's move to the next question. Okay, so Ravi travels a distance x miles in at the speed of s miles per hour. At what distance he needs to travel to double the distance in the same time? So what can we do here? Time is constant. Time is constant. So this relationship holds, and for this relationship, the initial speed is s, and the distance travel, let it be the distance travel be x, and the final speed is v, and it says that the distance, it's double the distance, so it is 2 times x. From here you can see that the velocity required will be twice the speed. This is the required speed, mph. Let's move to the next problem. Relative speed. What is the idea of relative speed? Well, when we have two or more bodies moving, we are interested to know how one body is moving, how fast one body is moving with respect to the other. There are two possibilities. One case will be when the two bodies are in motion and they are in opposite direction. They are in opposite direction. So what is this case? Suppose we have a vehicle moving in this direction at speed. Okay, let's use this. Suppose, and first case in the traveling the sun. Let's do the case where they are traveling in the same direction. Suppose we have a car A and we have a car B. This is moving with the speed v1, and this body is moving with the speed v2. In order to catch the car B, v1 has to be higher. That is understood. So, what is the relative velocity with which the car A speeds over speeds towards B? What is the relative speed of A with respect to B? That will be v1 minus v2. So we subtract. Let's see the other case. Second case, when an object are moving in the opposite direction. Let's see. It's the same speed v2 but in the opposite direction, and this is the distance between them. If I'm interested to know, like, what is this, how fast these two cars are approaching towards each other, in this case we will add the speeds. We'll add the speeds. That is what we have mentioned. The relative speed will be the sum of the two speeds. I hope you understood that. Let's do some problem and it will be better to understand. Let's do a problem. Okay, you can see this. You can see if the two velocities are moving in the same direction, the relative speed will be the difference of the speeds, and if they are moving in opposite direction, it will be the sum. Because why we added? Because we need to add it because the relative distance between the two objects is decreasing due to the speed of both the object. Okay, let's see an interesting problem. A thief car is running at the speed of 60 kilometers, spotted by a police jeep at a distance of 2 kilometers. So suppose this is the point, and this is the thief car, and this is the point of the police jeep, and at the point it got the information about it. It was spotted when it was a distance of 2 kilometers. The police jeep was at a distance of 2 kilometers away from the thief car. The thief car was running at a constant speed of 60 kmph. The police started its chase and was able to catch in 6 minutes. So naturally, from this point onwards, it has moved some distance ahead, and at this point, the police had caught. So this much, the thief was caught by the police. So this the time taken to travel this much distance was 6 minutes. So what is the speed of police with respect to the thief? That will be, we don't have the speed of the police car. Let it be s, let it be x. So speed of the police car with respect to thief will be x minus 60. So setting this, and the distance, if you are considering this has the speed, so distance we will consider, distance to consider will be 2 kilometers, because we are now interested with the relative distance between the two objects. Setting the equations of our motion, speed is equal to distance by time. Here it implies x minus 60 equals distance is 2 by time is 6 minutes. In hours, it will be divided by 60. To solve this, you will get the speed x as 80 kmph. Now, how much time the police jeep would have taken if the police jeep was less by 10 kmph? So, the stated speed is 10 kmph less. So, this speed, let it be 80 minus 10, that is 70 kmph. Wait. Okay, time taken by the police jeep to catch the thief, it would have traveled at 10 kmph less. Then what would be the case? Then that would be 80 minus 10, that will be 70. So at this speed, if you set the equations of motion, 70 equals 70 minus 60 equals distance 2 times t in hours, and this implies 10 t equals 2. So 2 equals 1 by 5 hours in minutes. If you multiply this, it will be 12 minutes. I hope you got the solution. Let's move to the next question. Well, this is an interesting case. Two cars moving in the opposite direction, coming towards each other. Let's write the speeds. Car A is moving with the speed v1 in this direction, and this is moving with v2 in this direction. And the distance between them is, although it's x miles, how much it will take the cars to meet? That is the distance by speed. Speed, the relative speed is equal to distance by time. So, and the relative speed here you can see is relative speed is v1 plus v2. So, distance equals time will be distance x by the relative speed, that is v1 plus v2. Similarly, you can see that for the second also, uh, they have reached each other. Suppose the two cars have reached each other, but they continued their motion in their respective direction in which they were already moving. In this case also, the relative speed will still be v1 plus v2, and the question asks how much time it will take so that they are x miles apart. Again, the same formula you will apply. Time taken will be distance x miles by v1 plus v2. I hope you got that. Let's move to the next question. Motions of motions of trains. They are interesting questions that there are some interesting questions you will find in motion of trains. Okay, so let's see the motion of trains. The first the first case will be a moving train and a stationary body such as pole. And if I talk about the length of a pole, we can say that it's almost negligible. So if we want to find how much time a train takes to cross a pole, the distance that we need to consider is just the length of the train. So let's see a problem based on that. A train covers 20 miles 20 meter away at an instant from a pole. So suppose this is my train and this is my pole. This distance is 20 meters. This distance is 180 meters. So how much time it will take to cross the pole? Speed is equal to distance by time. So time equals, this implies time equals distance by speed. And the distance in this case will be 180 plus 20 divided by speed, which is 30 kmph. And this will be in okay, this 30 kmph, this 180 and 20 is in meters, so you have to convert it into kilometers. So divided by 1000. So this will be motion of trains. So So let's see a problem. The train length is 180 meter long and is 20 meters away at an instant from pole. So let this be the pole and this be the train. Train length is 180 meter. This distance is 20 meter. We need to find how much time it will take to cross the pole. To cross the pole, it has to travel the length of its own plus this 20 meter. So distance will be 180 plus 20, and in kilometers it will be divided by 1000. That will be 200 upon 1000, that will be 1 upon 5. So how much time it will take? Time is equal to distance by speed. Distance is 1 by 5 times speed is 30. This will be in hour. If you want it in minutes, multiplied by 60. If you want in seconds, again multiply by 60. You can see that it will be 24 seconds. I hope you got it. Let's move to the next question. The second case, let's see what is the next case. Well, in this case, moving train and a platform of a fixed length. So, if you have a case like this, suppose you have a train of length x meters and a platform of length y meters. So, in order, if you want to, if the speed with which the train is moving is v, in order to cross the platform, you have to travel the distance of the platform as well as its own length. So total distance traveled will be x plus y. So and the speed is given to be v. So the time taken will be x plus y by v. But do remember that x plus y is in meters, so we need to divide it by 1000. So this is our answer. Let's move to the next slide. Two trains moving towards each other of a specified length. What we do in such case? So two trains are coming. This is the train 1, the train 2. The length of this is L1 meters, the length of this is L2 meters. The speed of this train is S1 MPS, meter per second, and this is S2 MPS. In order to cross each other, they are going to travel the relative speed of the train to cross each other will be S1 plus S2, and the distance it has to travel to cross each other will be L1 plus L2. So time taken will be L1 plus L2 upon S1 plus S2. Let's take the next case. Find the time taken by a train to cross a person running in opposite direction at a given speed. So what happens in this case? Suppose you have a train which is moving with a particular speed and the person is running in opposite direction with certain speed. So naturally you can see that the relative speed, the speed of the train is given to be 20 kmph. The speed of the train is 20 kmph. Oh, sorry. The speed of the train is not given. That is what we have to find in the problem. So let the speed be s, kilometer per hour, and the speed of the man is 20 kilometer per hour, 20 kmph in opposite direction. So relative speed will be s plus 20. Distance will be 4000 meter, will be 0.4 kilometers. So setting the equation of motion, you will get that s plus 20, the relative speed equals to the distance, that is 0.4 by time. It is taken 80 seconds, but we need to convert it into hours. So 80 times 60 times 60, which will give you s equals 80 kmph. Fifth case, find the time taken by a train to cross a person running in the same direction at a given speed. So if it is running in the same direction, so let this train of length L1 moving with speed V1 in this direction. There is a man is moving in this direction with speed V2. So relative speed will be V1 plus, sorry, V1 minus V2. So time will be distance, that is the length of the train, and that is given to be L1 by V1 minus V2. And this is your answer. Let's move to the next question. This has been asked in CAT 2004. Two boats are traveling at 5 and 10 kmph. So suppose the first boat is here and the second boat is here. This is moving in this direction with 5 kmph and this is moving in this direction with 10 kmph. The beginner distance is 20 kilometers. So they start the motion when the distance between these two boats was 20 km. How far apart they are in kilometers? 1 minute before they collide. So 1 minute before they collide, how far they are from each other? That's the question. So you need to see, just consider the last minute. If you consider the last minute before collision, the boat, this boat, suppose I call this boat as A and call this boat as B. Distance traveled by boat A will be what? This speed into time. Time is 1 minute, that is 1 by 60 seconds, so it will be 5 times 1 upon 60, that will be 1 upon 12 kilometers. Similarly, distance traveled by boat B in the last minute, the speed is 10 and the time is 1 minute. This will give you 1 upon 6, 1 upon 6 kilometers. So total distance traveled, total distance traveled equals 1 upon 12 plus 1 upon 6, that will be 1 upon 4 km. Thank you. Let's move to the next question. Average speed. So in the case of average speed, the universal formula is total distance by total time. Now, two things to remember here. When the distance covered is constant, we are talking about a constant distance. Then simply you can calculate the harmonic mean of the values. And let's see. Let's see the first problem. A body is traveling at distance of S1 and S2, and the average speed for the entire journey is harmonic mean of S1 and S2. That we have seen it here. If you want, you can derive it how, you can prove it how it is. So you can see that you can apply this formula. So total distance will be what? Total distance, suppose we are traveling with different speed. Let this distance be x. So total distance, in the case of bodies traveling constant distance with two different speeds. So wait. So suppose you travel the first x miles with the speed s1, and the second x miles with the speed s2. So total distance will be 2x, and the time taken will be x by s1 plus x by s2, and that will give you twice s1 s2 by s1 plus s2. So I have given you a proof. I've given you the derivation of this answer. Next question, if Ravi goes from town A to town B at a speed of 40 kmph and comes back at a speed of 60 kmph, then what is the average speed during the entire journey? So let's see, this is the town A, this is the town B. While going, the speed is 40 kmph, and while returning, it is 60 kmph. Distance, let it be x. So it will be, the total distance will be 2x, x plus x, that is 2x by x upon 40 plus x upon 60, and x will get cancelled out, and ultimately you will get 48 kmph. Let's move to the next problem. When the time intervals are same, this is a very in this case it's very simple. Simply take the arithmetic mean. Simply take the arithmetic mean of the distance, and that will be done. In fact, if several time intervals are given, suppose, and all are same, suppose uh, this distance it took in time t, traveled with the speed s1, it travel again in t s2, again travel in time t for this second, third, it's traveled with speed s3, and so on. Then in this case, the average speed will be s1 plus s2 plus s3 up to Sn by n. I hope you got it. Let's move to the next slide. Uh, well, a man travels in n kilometer in speed x kilometer per hour and n kilometers with speed y kmph. Find the average speed. Okay, so this m kilometers with speed x kmph, and this n kilometers with speed y kmph. So the average speed will be the total distance, that is x plus y, by total time. And time will be distance by speed. And this will be x plus y by, if we take mn, nx plus my, that will be x plus y times mn upon nx plus my. So this answer is wrong here. You can see that. Let's move to the next question. Well, streamboat question. In this case, the point what was given will be the what will be given is the speed of the boat in still water, and the speed of the stream will be given in a particular direction. So speed of the boat downstream, when you are going with the flow, your speed gets added. When you are going against the flow, your speed gets subtracted. And you can suppose we call this speed as a, so a equals u plus v, and suppose I call the upstream speed as v and write as u minus v. Using simplifying, solving these two equations, you will get that the speed in still water, that is u, you will get as half of a plus b, and you get v as half of a minus b. You can calculate, you can solve this two linear equations. Let's move to our next problem. A speedboat whose travel in 20 mph still water goes y kilometer downstream. Okay, suppose this is the initial point, and suppose this is my water body, river. Suppose it is moving in this direction. The speedboat comes. Stream speed of the steamboat is given to be 4 mph, and this is my boat. Suppose it's traveled this y miles, it, it traveled a distance of y miles and returned back, and it took 10 hours. So what will be the time taken to go, what will be the speed of the boat downstream with the flow? The downstream speed, which we call as A, will be 24. The upstream speed will be B, which will be 16 mph. You have to subtract this, and now you can set the speed of the motion. The time taken to go to travel y distance downstream was y by 24, and time taken will be y by 16 while coming back. That was against the flow, and the total time taken is 10. If you solve this, you will get to know that y is 96 miles. Okay, thank you for being staying in the class.